Hey everyone, it's Coding with Kareem, and today I want to make a continuation video on the last video, which was on goroutines and how we can leverage goroutines to use concurrency and write code that is asynchronous and make network requests that are non-blocking. So as you guys can kind of see in this code, we have three goroutines calling this fetch function, and all fetch is doing is making a get request to the URL. We are parsing the response body, and since we have multiple goroutines or lightweight threads writing to a global resource, we implement a mutex. So very basic code. And then once we finish firing these goroutines, we loop through our API data, and we're simply just going to log the key and the value. So let's actually run this code and see what we get. Okay, so didn't get anything, but that was just a bug. Okay, didn't get anything again. So the reason why this is happening is because the reality of the situation is that once we hit line 19 and we start iterating through this map, there's no guarantee that these goroutines have finished their work. The main thread or main goroutine is not going to wait for all of these goroutines to finish before it starts looping through API data. So even though this code may look correct, it's not, because by the time we hit line 19 and we try accessing API data, we have no guarantee that API data will be populated. So we need some way to at least wait for all of these goroutines to finish. We don't need the goroutines to run one by one, like we may have saw in our last video, but we do need a mechanism so that we wait for all of the goroutines to finish firing, and then we can continue on with the execution of our program. For those of you guys who have written a little bit of C, it's equivalent to calling the join method with a an actual operating system thread, like a POSIX thread. So let's actually implement this using a Go wait group. So we're gonna actually declare a wait group right under mutex. I'll call it wait group, and thank you so much, Copilot. So we'll do this. Let me actually turn it off because this is going to be annoying for this video. Cool. So now we have a wait group instantiated in our global program space. And a wait group is simply just a primitive that's essentially a counter, right? We're going to instantiate a wait group. We're going to add a value. We're going to set its counter to maybe 3. And then once that counter hits 0, then that wait group will allow the rest of our program to run. So right after the last coroutine runs, we're gonna call wait group, and we're gonna call the wait function. And if we look at the description of this method call, it says wait blocks until the wait group counter is 0. And before we actually run any of these goroutines, we're going to give the wait group a value. So let's do that. I'm going to do wait group. I'm going to do add. And since I know we have 3 goroutines firing, I'm going to give it a value of 3. Right? So we're going to have our wait group instantiated with a value of 3 or set to 3. We're going to have 3 goroutines firing. And the idea is after each one of these goroutines fires, we're going to decrement the wait group counter. And we can actually do so, and we're advised to do so in the actual goroutine itself. And since wait group is declared in global space, we can just do that within the fetch function itself. So we're going to use the defer keyword. We're going to ensure that this runs at the end of our function call, and we're going to say wait group dot done. Right, let's look at the description, and it says done decrements the wait group counter by 1. That's exactly what we want. We can also call wait group dot add and just pass in -1 if that's a little bit more intuitive for people. So that's exactly equivalent, right? So each one of these goroutine, after it finishes its fetch function, and it writes to our API data, and it unlocks the mutex, it's going to call this wait group add, and it's going to give it a value of -1, essentially decrementing our counter. And wait is just going to block until it hits 0. And once that happens, we can safely iterate through API data, and we know that all of the goroutines have finished populating our global map. So let's actually run this code now. And we should actually see stuff in the terminal. We should see some beautiful stuff. And as you guys can see, we get amazing stuff in the terminal, right? We get the key, the actual URL of the server that I'm running locally, and then we get the value, right? So for singers we have Gucci Mane, Taylor Swift, and my favorite Ice, JJ Fish. If you know, you know. So that's essentially it. That's a way we can use a wait group to actually synchronize goroutines and ensure that we don't have code that isn't intuitive, right? Because without this wait group, our main thread would have continued looping through this API data. It would have had no data, and our program would have exited. Um, so that's not honestly that's not correct. So a wait group is just a way for us to consolidate that. That's essentially it for this video. The next video is going to touch on another concept in Go, which is using a channel. As you guys can see, we're using a mutex to protect this API data map because multiple Go routines are going to be writing to it. If we were reading from it, it wouldn't be an issue. However, Go doesn't prefer mutexes; it prefers something called channels. So in our next video, we're going to change up our code a little bit and implement channels and make our code a lot more Go um, idiomatic. I believe that's the word. Have a great day. Thank you so much, and goodbye.